Okay, so today is the day 14th of November 2013. So I have been working out in other projects that I have. So for the completion of the project of today, my old project, it started to be a joke, but end up one of the best motorbike project ever. So at this moment the sketch is a little bit childish, but it is the basis for a more high-tech advanced technology. Same thing. So let's start with the old one. I even draw the specific each single part of it. Well, many electrical parts, obviously they are standard in the world, and to be able to use it we have to obviously pay. Even so, here it goes. This was the joke which I'm going to show you. This actually was the joke. I put it RF antenna over here, symbol, joystick symbol, diodes, a jack-in, a resistance, a hear speaker, and a microphone, and a special buttons and configuration that you will access to. This was a joke only because the resistance, because here is not the correct place for the resistance. It's a private. This is the component that I need to fabricate what I need. This is a part also that I designed it myself to increase and maximize the power. I call it a VMAG. This is the standard for a radio transmission systems from F1 pilots and MotoGP pilots, but I have way more improved packets over here. So in this part over here, I call it Electro because it was one of the first magazines that I have read about electronics and how to build integrated circuits boards. So this is the general idea of the system to be implemented in motorbikes. In Portugal we call rodoviária, lei rodoviária, in English traffic law. This is my black box. It's extremely safe, extremely simple, respects all the privacy statements all around the world, because you don't have cameras. It is not allowed to have cameras. It's all controlled in the small parts that is inside of the bike itself. The first candidate to buy this actually is the Kawasaki motorbike brand, because I have a small crutch, or you may say I'm a big fan of Kawasaki. Besides of making download of Yamaha for the software, because I didn't find no Kawasaki Ninja render, but I will make one. This is a very specific part. So this is the components needed: 3xi5 plus 1. This is what it needs: rack spot sensor, set weight, calibrates, minimap down, set hole, rack map, planities. All this means small parts, okay? This is very easy, and for a technician he will understand what is this. It's the best black box for a motorcycle that you can have. and it is also implemented and nicely implemented in a car, respecting the person's privacy, because it's their vehicle. They can walk at any speed they want. If you use the black box that is being built in United States of America, you will lose your privacy. You will lose the majority of your privacy, and it will be, on the moment that you drive your bike, it will be incommodative. It will always knock at your head, oops, 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 and probably you will have a crash. This is the part, the motherboards, to be implemented inside of the helmet. It's more smaller than, in fact, but this is the correct size to put on the helmet on the back part, and it will not cause harm to your brain even if you shock it. I try it. So this is the internal DAC plus one that I didn't put here. I will have two internal DACs, each single one of them 512 megabytes. This is the controller for the ramps to identify inside of an Android or iOS system. The feeding system is separated for two reasons. First, I don't want it to overburn or short circuit in any way, and in case of a crash and in case of snap, this motherboard is actually built to pre-snap in three parts, leaving the electricity field separated from the Bluetooth field, and the microprocessor is here. So this is the controller, this is DAC plus one DAC. This is the bridge for the components that we have here, and to control the signals from Bluetooth. You can possibly add a camera by your own, and to control exactly a small system that will actually communicate with the Android. It's a self-independent system. This part over here is where is going to stay your black box. This part you can remove actually. This part is what it will actually process all image, all sensors, everything that is put it. This over here is the software. Actually, it was built in HTML because it was to work with the C+ programming, and HTML on the time it was the only language that I knew, including PHP. This is a special software. It has racing mode, cruise mode, discovery mode. Okay, this will not make your bike to move alone. You have to drive it anyway. But each single mode has specific ways and specific modes on how to process the signal from your GPS, from your smartphone, and the way how it will measure distance, obstacles, and how it will record it, how it will show you the road, and the possibilities to show you, in Portuguese you say manómetros, the speedometer, rotation meter, stuff like that. Completely different. So the first part over here is the setup of the application itself, where the data to be used by all of them, all these boards over here, they will be set up in the first screen. Since Android and iOS don't have actually an installation Windows lookalike, if you may say, where you can actually during the installation do the configuration. So we're gonna do it after. It will be all kept inside, not inside of your Android, but inside of the microprocessing board. All data will be saved here, and from here we'll go nowhere. The only thing that you can do here is to save some text files with a few datas. that will actually be thrown or dumped to the last page when you press stop on automatic stop. It depends on what you want. As you can see, you have here the identifier, timer control allocation, because you need time. You need a timer control to know exactly, to work with the GPS, to know exactly your allocation and to know the allocation of other obstacles. This is the specifications of the software that actually I am already building. This is the first setup page. As you can see, name of the pilot, age, sex, weight, name of the bike, year, power, weight, model, gas capacity, other details that you may want to put, like stickers from Chinese, stuff like that, serial numbers, everything that you may want to put inside of other details. Voice recognition is really needed. You have call team, call adversary, current speed, zone, intersection, next turn, gas pump info, which is the current deposit, RC mode, cruise mode, discovery modes. And this is the voice recognition commands that it does work. Then you have the track set that is more complex, and I needed the timer control to be able to do this. I will not explain you exactly 100% because this is the secret of the software. This is the new, plus this is the new. But this is already implemented in the Android system or inside of iOS. This is not even implemented, but it will work. This is the project that started at 27/10/2013, based on the jobs that I have been doing since 1999 for my planators, or a small planator. Let's go to other.